All right, so we're going to talk about the quasi-symmetric quartic equation, which has its form of a x to the power of 4 plus bx cubed plus cx squared plus b mx plus a m squared is equal to 0, where m is a number like 1, 2, or a negative number as well. So how do we solve this? Well, if we go back to my other video, we could go ahead and simply solve this using Ferrari's method by depressing and removing the bx cubed term. But we're going to go ahead and look at this specific quartic that is solvable without Ferrari's method. So we're going to go ahead and divide the whole equation by x squared. So we have ax squared plus bx plus c plus b m over x plus a m squared over x squared. And here we have a, or we could simply just factor out a from m squared over x squared and x squared. So once doing that, we have a times x squared plus m squared over x squared plus, and we could factor out a b from x and m over x, so we have plus b times x plus m over x plus c is equal to 0. So we have somehow made this equation almost into a quadratic that we know and we could solve using the quadratic formula. But how do we have the inside be a variable like x or y or z? For that, we would have to look at this term right here, x plus m over x. And by doing so, we will have to make a substitution. So we have z is equal to x plus m over x. And now we could directly plug in z for x plus m over x, and we will get bz. Now, how do we find a variable that we can make it to z squared so it is a quadratic? So the idea is to square z so that we have x squared plus 2m plus m squared over x squared. And we have x squared right here and a mx, m squared over x squared as well. So what we have to do is introduce a 2m into the equation, but also on the inside. And if it's inside such that it makes z squared, we have to also subtract 2am. So the equation we will now have is simply a times x squared plus 2m plus m squared over x squared plus b times x plus m over x plus c minus 2am, as this maintains the equality of the equation. So now we could use z and replace everything inside the parentheses with a z, so we have a quadratic. So we have az squared plus bz plus c minus 2am is equal to 0. And now we can go ahead and simply solve this quadratic that we have here by using the quadratic formula. So we will get z is equal to minus b plus or minus the square root of b squared minus 4a times c minus 2am all over 2a. Now we could simply replace z with our substitution we made earlier. So we have z is equal to x plus m over x. And since we already found z, now we could replace z with our substitution. So we will have x plus m over x is equal to minus b plus or minus the square root of b squared minus 4ac plus 8a squared m all over 2a. So here we now see that if we multiply by x, we will get a quadratic. Again, well, we would have to solve that. So we're going to multiply everything by x to get rid of the x in the denominator in m over x. Once doing that, we will have x squared minus negative b plus or minus the square root of b squared minus 4ac plus 8a squared m over 2a plus m is equal to 0. So we will go ahead and solve for x now in terms of a, b, c, and m. So let's just rewrite our equation up here. So we have x squared minus negative b plus or minus the square root of b squared minus 4ac plus 8a squared m all over 2a x plus m is equal to 0. So we will again have to use the quadratic formula to find x. So we will have x is equal to, since this is negative, it will just be positive, leaving us with minus b plus or minus a square root of b squared minus 4ac plus 8a squared m over 2a plus or minus the square root of this expression all squared minus b plus or minus the square root of b squared minus 4ac plus 8a squared m over 2a squared minus 4m. And that is all divided by 2. So here we already have a solution, but we would like to simplify this so we have a more simple and general solution. So if we simplify the minus b plus or minus square root expression, so we will have minus b plus or minus the square root of b squared minus 4ac plus 8a squared m all over 2a squared minus 4m is equal to, so we're going to square everything, so the bottom just becomes 4a, 4a, and using the difference of squares or a perfect square formula, we will have b squared plus or minus 2b times the square root of b squared minus 4ac plus 8a squared m, and all of this squared, so that we will have plus b squared minus 4ac plus 8a squared m. And since we are also including the 4m, we will get minus 16a squared m. So simplifying that on the inside, we will go ahead and see that the denominator will become 2a. So we will have to join the expression for b squared plus or minus 2b, the square root of b squared minus 4ac, and so on, all into that single expression. So we will have x is equal to minus b plus or minus the square root of b squared minus 4ac plus 8a squared m, and then with all of this included, plus or minus the square root of b squared and b squared added, that is 2b squared, and we have minus 4ac, and we have 8a squared m minus 16a squared m, which is minus 8a squared m. And since we have this 2b, we're going to have plus or minus 2b times the square root of b squared minus 4ac plus 8a squared m. And that is all divided by 2a, again, all over 2, which is going to be the same thing as 4a. So here we have a plus or minus here, a plus or minus there, and a plus or minus here. So how do we know which sign to use? Well, the right signs to use when using the general formula for the quasi-symmetric quartic is plus, plus, minus, 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 plus, and plus, minus, minus, as well as minus, plus, plus. So that is for the first solution, the second solution, the third solution, and the fourth solution. So just I line them up in this certain way so that we see which one it corresponds to. So when using the formula, we will have minus b plus the square root of dot 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 plus the square root of dot 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 minus 2b times the square root of dot dot dot. And the same thing goes for the second solution. Minus b minus the square root expression minus the square root of 2b squared dot 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 plus 2b. And the same thing happens for the third solution, which is just minus b plus, and then this expression minus the entire square root expression and minus 2b. And then the fourth solution is just negative b minus the square root expression plus the square root expression plus 2b and the square root expression. And that's the general solution to a quasi-symmetric quartic. So let's go ahead and walk through a example. And the example we're going to use is x to the power of 4 plus x cubed minus 2x squared minus x plus 1 is equal to 0. So here we have to simply identify what is a, b, c, and m. So here we see that we have a is equal to 1, since the leading coefficient is 1. And we have b is equal to 1, since we have 1x cubed. C is equal to negative 2. And since we have the negative here, we can assume m is equal to negative 1. Because the x term is simply b m x, and of course 1 times negative 1, it gives negative 1, and the x is in the front, so we have negative x. And negative 1 squared is simply just 1 times 1, which is again 1. So we have a symmetric quartic here. So now we're going to go ahead and try to solve it again by doing the substitution. Z is equal to x plus m, which is negative 1, so it'll be minus, or it will be plus negative 1 over x. And we're going to divide by x squared, so we have x squared plus x minus 2 minus 1 over x plus 1 over x squared is equal to 0. So we're going to go ahead and just factor out this so that we end up getting 1 in the front, since we already had to factor out a 1 and negative 1. So once doing that, we will simply just get x squared plus 1 over x squared plus, and we have the x's, which are just 1. So we will have x minus 1 over x minus 2 is equal to 0. So we could simply set this all equal to 0. Well, not this expression, but we could change x minus 1 over x with z. So we have z minus 2. And of course, we're going to square z. So we have x squared minus 2 plus 1 over x squared. So we have to include a x squared minus 2 plus 1 over x squared plus z minus 2, and we're subtracting the 2, we have to add a 2, which is equal to 0. These two cancel out, and we are now going to set this equal to z, so we have z squared plus z is equal to 0. So we could factor out a z, giving us z times z plus 1, and we get z is equal to 0 and negative 1. And now we're going to set z back to x plus 1 over, or negative 1 over x. So we have x minus 1 over x, which is equal to, we're going to use both of the solutions we got from z. So we're going to have 0 and x minus 1 over x is equal to negative 1. So we'll rewrite those two quadratics now, which are x squared minus 1 is equal to 0, and x squared minus 1 is equal to negative x. Solving for the left quadratic, we get x is equal to plus or minus 1. Now for the second quadratic, we have to move x to the right side, or to the left-hand side, so we have plus x minus 1 is equal to 0. We will use the quadratic formula, so we will have x is equal to negative 1 plus or minus the square root of 1 plus 4 over 2. We can simplify the square root, which is 5 over 2. And here we have four solutions, plus or minus 1, and the plus or minus in front of the fifth or the square root of 5. So we will just verify that this is a solution since that is a much more easier example. So we're going to set x is equal to 1. So we have 1 to the power of 4 is 1. So we're going to have plus 1 cubed minus 2 times 1 squared minus 1 plus 1. So here we just have 1 plus 1 minus 2 minus 1 plus 1. These two cancel out. And 1 plus 1 is 2. And 2 minus 2 is 0. So we see that 1 is a solution, and so will negative 1 be a solution. So we could go ahead and try to see if these are a solution, but we're not going to plug them in. Rather, we're going to directly divide by x squared minus 1 with the whole quartic. So we're going to have x squared minus 1, and we're going to have the fourth degree, or quartic, on the inside so that we could divide it to x squared minus x plus 1. So we're going to have to multiply by x squared. So we get minus x squared minus, or x to the power of 4, minus x squared. So we have plus 0 minus x squared. And this will give us 0 x cubed minus x squared minus x plus 1. And we're going to go ahead and have to multiply by x again, so plus x. So we have minus x to the power of 3 minus x, which is in turn going to be 0 and minus x squared. And these two cancel out, and we have plus 1. And we see that if we just have, again, negative 1, we will end up getting that if we multiply this by negative 1, we will have negative x squared plus 1, and we subtract that. That will then be negative x squared plus 1 subtracted by negative x squared and positive 1, which will then cancel everything out. So we see that this here is is the solution to our quartic. So we didn't have to directly plug in the solutions. We just divided out the solutions that did work, that were rational, and we got x squared plus x minus 1. So we could see that solving these quartics are rather simple, but we just have to determine what M, C, B, and A are. So that's it, and yeah, thanks for watching.